Okay. Moment. Okay. We are online. Hello, friends. Welcome to Java channel with Philip. Philip, introduce yourself, please.
Yeah, no problem. My name is Philip. I'm a software engineer at Red Hat, and I'm going to talk about MicroProfile GraphQL, which is something that I've been doing for the past year and a half or so. Okay, so
let's start.
Okay, let's go. So I'm going to start off by So I'm going to start off by basically telling you a story, or more specifically my story, on how I got to GraphQL and hopefully give you enough context. And then we'll talk about GraphQL in general. Then we'll talk about MicroProfile and the MicroProfile specification. And then we'll look at some examples using the small array implementation. And if there's time, which I'm sure there will be, we'll look at what are we working on next, so what is the next version of the specification. All right, so let's start with painting a picture or giving you some context. So a few years ago, I was working at a big company, a big insurance company, and we did all sorts of insurance. We did short-term insurance, so insuring your car and your house and your TV and whatnot. We did health insurance, so when you get sick, you have to go to the hospital, they'll help pay. Life insurance, so if you die or somebody dies, it gets paid out. We did some wealth management, employment insurance, and all of these business units in this company was actually small little companies of their own that had their own CIO, or still have their own CIO, their own IT department, and their own systems. And then we had a way to connect to the client, and mostly this was via a broker. So a client would contact a broker, or they would phone a call center, or they would use the website or the mobile site. And all of these ways to interact is a different company with their own IT systems and their own CIO and operated on their own. And where I was working was kind of in the middle of all of this, because usually dealing with your insurance company is a fairly negative engagement. If you have to deal with your insurance company, it usually means something bad happened. Either you bumped your car, or your TV got stolen, or you're sick, or you died, even worse. And you now have to speak to the broker or log onto the website. So it's not an engagement that you do often, but if you do it, it's a bad engagement. And our job in the department where I was working was to make sure that we can actually change this engagement with the insurance company and make it to be more frequent and positive. So our job was to basically make the client happy. The way that we decided to do that was we would create a profile of the client, and then we will score that profile, and then we'll reward the user based on that score. And we were obviously a team of our own with our own IT systems. Now, what we've done is we would integrate with a local gym or local sports club and understand that this user is a fairly active user. They go to the gym, or we also integrated with your smartwatch to be able to see how many steps that you take or how many calories that you burn, to understand that you are active and living a well lifestyle. We would integrate with your car, the tracking system in your car, to understand how do you drive, so that we can reward you if you drive within the rules of the road. We would integrate even with the banks, understand how you spend your money, and if you spend it wisely, then you get rewards. And then with this rewards, you can get discounts at a shop, or discount flight tickets, or discount at a coffee shop, or we also had our own online shop where you can buy things with discount, getting discount. Now, the point of this is what we have done is a lot of integration. We had to integrate with all of these third-party vendors that provided us this information, and all of these partners that allow us to get discount on the store. And then we have to integrate with all of these other departments because they want to get this profile of the user to understand the user better. Now, when I started working there, which is now about 5 or so years ago, there was a lot of legacy systems, as there is with any big company. So a lot of this integration actually happened with FTP, or there was some SOAP services, or even straight RMI. The biggest part of the system is actually running on AS400, which is a fairly old system. And then there was some modernization happening on Java. So when I got there, we decided that we want to modernize this application, and we want to make sure that it's ready for the cloud. It's API driven, it's well documented, and we decided we're going to build REST endpoints. It's going to be awesome, and it's going to solve all of our problems. So the first thing that we did is the website team wanted to rebuild their website, and they used Portal, and they want to use our brand new REST service to be able to display the profile of the user onto the screen. So they need the profile and the user details and the score that we gave the user. That would mean that we would have to make a call out to our partners to get this information and send it back to them. Now, I'm going to show you some code. This is, it's not the real code of this company that I'm talking about. It is just very similar to explain the use case. So if you know JAX-RS, and this is very similar for Spring Web, to be able to create a REST endpoint like this one, where you want to return the profile of this user, we allow you to annotate your method with @get, and the path would be passing in the user ID as a path parameter, and then we'll return a profile object. A profile object is made up of some ID and then the person itself and the score that we gave him. A person, in our case, was actually quite a big object. It had 70 plus fields in it, and it was coming from a system that was not maintained by us. It was maintained by a different department that was maintaining shared services. And this actually ran on AS400. And then the score was our system, which we linked to that person and then give the score that we gave the person to be able to create the profile. So a profile is really just made up of these two objects. So the data that came back was a JSON file over the REST, and it was fairly big, but it was working quite well. The web team could have found all the parts that they're interested in this JSON file, and then they can display it on their screen, and they're happy. So the web team was happy, they went live, and at that same time, the mobile team heard about our new REST endpoint, and they wanted to use it. However, they are not interested in this huge JSON file that we return, because they're running on a phone which has a potentially bad connection, and they don't want to process the JSON on the client side. So they asked, can they get specific things and not the whole JSON? So we said, okay, let's go read page 2 of the REST manual and see what do we do. So one of the things that we came up with was a concept called Hatios. What Hatios does say is that rather than returning the full JSON file in the response, which is very big, break it up into consumable pieces and just return the URL to that piece. So as an example, a way that we could do it, oh, by the way, Hatios is awesome and it's going to solve all our problems. So a way that we can do it is break up person and scores, where if you make the initial call to profile, we will return a URL on where you can get the person. and a URL where you can get the score, and you can make those 2 calls again and then get the data back. The problem with that is that we now have to make 3 calls to get all the data that is way too much back. So the mobile team wasn't really impressed with that solution, and neither were the web team, because they already have a working solution. So we said, okay, what else? What else can we look at? So what about best friends forever, BFF? It's not really best friends forever. It's a pattern that's called backend for frontend. And what it says is, in our case, the web team can continue as per usual, make a call, get the whole JSON back, parse it on their server side, because Portal is a server-side technology, and display it on the screen. The mobile team, however, will have to build their own backend, which will get the data, as the web team does, sanitize it on their backend, and then send it down to the mobile phone. Obviously, the web team was happy with that solution, but the mobile team is not happy because they don't want to build a backend. They are primarily a front-end team. So what did we end up doing? We created something like this, Profile Light, which is a new object which only contains the fields that the mobile team is interested in. It has a new URL. The mobile team can now call that and get the data that they want. Now both teams are happy. We weren't that happy, but we can continue. At that same time, the online shop, which was a third-party vendor that built this shop for us, was redoing their CMS in some new JavaScript framework, and they want to display some details of the user on their online shop. They kind of want exactly what the mobile team wants, except they also want status. So, which means following the pattern that we used up until now, we have to do something like this. Create a new object, called it Profile Light with status, populate it with all the fields from Profile Light plus status, give them a new URL, and they can continue. And what we've realized at that point is that this is not a scalable solution. We cannot go and create a new endpoint for every consumer to actually help them with what they exactly need. So one of the things that we then thought about is, should we play with removing the 2 ugly Profile Light and Profile Light with status, and play with passing in query parameters where the user or the consumer can exactly say, what is it that you want to get back? So kind of an include or an exclude or combination of the 2. I'm sure this would have worked. The problem with this is that the consumer will have to know how a profile object looks like, and especially if it's a fairly complex tree, using some sort of dot notation to specifically say which fields do they want. So it would be very hard to document and to use. So what we've realized at that point is that we have the problem of overfetching and underfetching, where overfetching is when we fetch too much data and the user needs to filter out exactly what they want, or underfetching where we didn't give enough data and they have to make subsequent calls to get all the data that they want. And obviously the worst of this is a combination of the 2, where you underfetch, so you have to make more calls, but the subsequent calls actually overfetch. We also knew at that time that all the departments is busy modernizing their systems, and they all want to make a call to our system to get this data, and they all have their own small requirements that they need. So back to the drawing board. Surely someone else have these issues. So we already kind of looked at Hatios and BFF. So at that point, we decided what happens if we Google queryable REST. And what you will get is something called GraphQL. It is awesome, and it's going to solve all your problems. So let's talk a little bit about GraphQL. It was a project started by Facebook. It's open sourced. It's just a specification, and you can go find the specification online. It's been positioned by Facebook as an alternative to REST, even though I believe you should be able to use the 2 together if you want to. It's being positioned as declarative data fetching. solving the problem that we've just described. Facebook specifically started looking into this alternative to REST because of their increase in mobile usage. And it's specifically the mobile phones that, depending on the phone spec, or even if we start looking at other devices like smartwatches, the ability to be able to query the data and only get back what you want over the wire, because it's that network traffic that's expensive. And they also have a variety of different front ends, and they want to make sure that these front ends can work independently of their back end. And we'll get to that a bit later. So that will enable rapid feature development. They've been doing this since 2012, and it's been publicly available since 2015, so it's not brand new technology. So some of the benefits of GraphQL is, like we've mentioned, the data fetching. So we solve the over and under fetching problem. The development speed, the fact that a front-end team can actually query exactly what they want on your endpoint without you being involved, means that they can rapidly iterate on their own without involving the backend team. With a REST, like I've mentioned in my example, every time that we have a new consumer coming on, they have to set up a meeting with us, discuss the endpoint, tell us what fields they are interested in. We have to build a new one. They have to wait until we publish it, and then they can start. And then the other benefit of, or one of the other benefits of GraphQL is it has a built-in schema, and it's a type-safe system, where with REST, if you want a schema, you have to use something on top of that, like OpenAPI or Swagger. So there's this website called howtographql.com, which is a very nice website. I can recommend it if you want to just get the basics of GraphQL, understand that. I'm using some examples from there. If we look at a REST example, in our case, we would make a call to the profile service to get back the profile, which will give us a link to get the person. So we'll make a call to the person service, and then we'll get an ID back to be able to go get the score for that person. And then we'll aggregate those three, filter out the data that we don't want, and then send it to the screen. So that's how the REST will work in our example. In GraphQL, what you can do, you can make a call to the profile endpoint. You can tell it exactly what is it that you want, and it will return exactly that, which means the web team can ask for specific data, and the mobile team can use that same endpoint, ask a different question, maybe less data, and they'll get less data. So some of the concepts in GraphQL, before we continue, just so that you have some context. It has operations. The two that we would look at now is queries, which is asking for something. So in a traditional database type application, if you think of CRUD, this will be the read part, the R of CRUD. And then we have mutations, which is any time that we actually change the data, it mutates. So that will be everything but the read in CRUD, either update, create, or delete. There's also something called subscriptions. We're not going to talk about it now. It's also not yet implemented by MicroProfile GraphQL. It's on our to-do list. And then there's some objects or types within GraphQL. The first one is, it's called a type. It's really the output type or the result of a query or mutation. There's an input type. So when you ask a question and you have to pass something in, that will be an input type. And then there's interfaces, which is fairly similar to a Java interface. Enums, which is similar to a Java enum, and scalas, which is similar to a primitive type in Java. So if you look at this, you'll be able to actually see this in the schema. This is a generated schema from our example application, and you can see that we have an output type of address and credit card, an IAM client, and then we have an operation, delete person, which is a mutation. I'm getting back a person, I'm passing in an int scalar. So that schema is fairly readable, human readable, even though it's for machines to read, but you can kind of read the schema. One of the other nice things that GraphQL have out of the box is the ability to do introspection. So you can use GraphQL to query the schema. So in this case, I'm doing a GraphQL query on this schema, and I ask back all the types, and I only want the name, description, and kind of that type. And that's the result. So that's quite handy. Okay, so that's kind of a background on GraphQL in general. So next, I'm going to talk about the specification, MicroProfile specification. I'm sure most of you would know about MicroProfile, but just quickly, it's a umbrella specification, umbrella specification that contains all sorts of specifications related to cloud or microservices architectures. So this is 3.2. I think 3.3 is out. I should update the slides. The building blocks of MicroProfile is APIs that exist in Java EE or Jakarta EE, CDI, JSON-P, JAX-RS, and JSON-B. And then there's a whole bunch of APIs on top of that that enables microservices type architectures like fault tolerance, metrics, health, and so on. And the process, how this works in MicroProfile, is that if we want to propose a new API under the MicroProfile umbrella, is that we'll first add this APOC in the sandbox. So the sandbox is where we play. And once we're happy, we take that POC or an example application or whatever to the community and propose it as an API. It then gets accepted or not. If it's accepted, you start building this API as a standalone API, meaning it's under MicroProfile, but it's not being delivered as part of the umbrella specification. So that's kind of where GraphQL is at the moment. We've a month or so ago, we've released version 1 of the spec as a standalone specification. And then if it works well and it gets adopted and people are using it, then you can go back to the community and propose to include it under the umbrella. Right, so the MicroProfile GraphQL is available in GitHub. You can go see it there. What it means to be a specification under MicroProfile is basically there'll be a spec doc, which we've used ASCII-doc to actually write that spec. So you should be able to download the PDF version or browse the HTML version online. It's the actual API, so that's usually Java interfaces or Java annotations. It's the set of tests that an implementation have to pass to be able to compliant to the specification. In our case, we use test-ng. And then finally, to actually release a version, you have to have a compatible implementation, which we have, and that's the small RAI implementation I'm going to show you a bit later. Well, right now. So I'll now show you some examples. I might have to switch between the screen that I'm sharing, which might be annoying, so we'll see how that goes. I'm going to show you an example that's available on GitHub under my GitHub account, Phillip Kruger /GraphQL example. So I'm going to actually, before we go here, I'm going to start checking it out. I'm going to start from scratch, so a brand new machine, clone it, and show you how you can actually do it yourself. So I'm going to try stop sharing this screen and share a new one. And I'll go back and forth between these two. So I'm hoping you can see my command line now. Yes. So this is just my temp folder. I'll go and clone this repo as I've shown you. And once you've cloned it, you can compile it. So Maven clean install. It's a very basic application. It's running on Wildfly 19, and it's just adding the small RAI inside of your deployable unit. So now if I go to the person example, I should be able to do Maven Wildfly run. So you don't have to install Wildfly. This will do it for you if you don't have it installed, and it'll deploy the application. It uses some library called JFaker, which just creates a bunch of random data, which I basically create data to populate this object model of ours. So there'll be 100 people in our people database being deployed. So you should see, okay, all test data generated, ready to go. Now I need to switch screens again. This is really going to be annoying, but let's share this one. Okay, so if you go to that GitHub account, you'll also see I've tried to document as well as I can, so you should be able to do this yourself. And we're going to kind of go through this now. The first example, we'll just look at JAX-RS. So if you go, after you've started the server, if you go to localhost 8080, there's a static page there that just allows you to click on REST, which will open Swagger UI, which is a UI on top of Swagger, and Swagger is a way to document your REST inputs. And that's the other nice thing about GraphQL, is that you get that with GraphQL. It's not a separate API like a JAX-RS and Open API. Once you use GraphQL, you have a documented endpoint. So as an example, our example, we'll go and find that person by ID. Let's say ID1. Now, as I said, the person object is actually quite big. In our example, it was quite big. It was like 70 plus fields. So this is one person. It's quite big, especially if I want this person only the name and the surname, and I'm on a really bad cell phone connection. And then obviously with this way, we will now here find the ID, which is somewhere in here. And then we can use that ID to go to the score service, make a call on there, and we'll get this back. And if we aggregate the two, we can get all the data that we want and filter out the ones that we don't want. So that's how we kind of did it in the REST. In that same example, we'll look at how you can do it in GraphQL. Now, GraphQL also, similar to Swagger UI, has a front-end called GraphQL, which is really just a JavaScript front-end on top of the endpoint that's been generated. So I actually now need to quickly, before we do this, switch back to my presentation. I'm potentially just going to do this so that I don't, so I'm not going to go in present mode, and I don't have to switch screen sharing. So let's go here. Right, so what we're going to do in demo one is we're going to, well, we've already queried this in JAX-RS. Our JAX-RS system was still just a plain old JAX-RS that returns the profile, as I shown previously. So we want to do something similar with GraphQL. I think I'm at the wrong place. So the JAX-RS one, I hope you can see there. The JAX-RS one would look something like this. And here I've added the operation, which is coming from Open API. So this allows me to document the endpoint using Swag, Open API. So all that this does is it goes to the person database, get the person, then it goes to the scores database, get the scores. It combines the two and it returns a profile. So that would be actually not the person one. That would be actually one where we don't use @, where we use the profile service, this one, right? So it'll even, the original response will even be bigger. So this is the full response now, the aggregated version of the two. If I want to do the same in GraphQL, I can actually now open that GraphQL, and I'll just start from scratch. So first of all, you can see the actual document, so you can explore it. You can see what queries are available. How does a person look like? Like I said, it's all built into GraphQL. So as an example, to do something exactly like we've done in JAX-RS now, we can do profile full. I can say that I want to pass in person ID 1. And now I can actually say, what do I want back? So I want back the person only the names and the surname, and then I want back the scores and the name and the value. So now I get back exactly what I've asked for, which is obviously much smaller payload than the one in JAX-RS. So I'm just going to close some tabs here so that I don't get confused. Okay. So, and to do that in GraphQL, if you look at, this is how we've done it in JAX-RS. GraphQL is pretty much exactly the same, except the annotations has changed. So the method is exactly the same, except that I now annotated with add query, which will tell small r GraphQL that this is a GraphQL query. You can optionally add a description if you want to. And the rest is all optional. You can change the query name if you want to. You can change this parameter name if you want to, but otherwise it will pick up that person ID. So that guy here, it just gets it from this name. And then the rest is the same, right? So fairly easy to actually get GraphQL, MicroProfile GraphQL going. You can use it on your existing services. Okay, but what we want to make sure is that if the query, so the person that is asked, maybe the mobile team asked, use GraphQL, and they said that we want the person's name back, and they never asked for the score. We want to make sure that the score doesn't get called, because that might be an expensive call. In our case, my example, this was two separate systems, and the one was AS400 and the one was Java, and one was actually quite slow. So penalizing a user to go and fetch the score if they actually didn't ask for it is what we want to try and avoid. So we want to remove this call to the score out of this and move it to a separate method. You can do that in GraphQL by just annotating, can you see here? By annotating it with at source. And what will happen now is that as a request comes in for a profile, if that profile contains a question of scores, only then this method will be called, passing in the profile, which was a result of this method, and then aggregating the data for you. So now I have to switch screens again because I want to show you the log file. So I'll do it, and then I'll show you the log file. I'll clear the log file on my side, and then you won't have to change screens once. Right, so to do that, we're now going to actually call profile, and we'll again pass in the user ID. We'll make it 2 this time, and I'll say I want back the person. Let's ask for names again, and surnames, and then we'll want the score, and the score name, and the score value. Right, so that's the same data that we got back previously, and I've aggregated scores and person. So I'm going to just clear the log file a little bit so that you can see it just now when I share. But what happens if I don't want the score? I want to make sure that that expensive call is not being made. So now the data is less, and let me quickly share this screen, which is now the log file. You'll see that the first call happened, which was the one that included scores, so both methods was called. But in the second one, we don't call the second method, which could be a call to a very slow system. So that's how we solve that problem, is the ability to actually annotate something with at source. Okay, back to this one. Okay. So what we've realized now is that we actually don't need the profile service anymore, because, and now in this mode you can't see my annotation, let's do this. Yeah. So we realize that we don't need this part, because we can just aggregate these two right on the boundary by adding the source. So even though the person object doesn't have a field in the Java class that's called scores, I can add that field in GraphQL right on the boundary by doing what we've what we've done now. So I removed profile totally. I now have a person, and a person just goes find the person of the person database. And then I have a score, which I can say that you can add a scores field to the person object. In the case that they've asked, if they ask that, I will call this method and aggregate them. And then it will have the same effect. It will only be called when you ask for it. So if we go back here, rather than calling profile, I can just call person. Let's go person ID 5. And now I can say, give me the names, surname. And now you'll see that I actually have a score field on here, which is not on the Java class, but it's available in GraphQL. And then obviously I can tell scores what I want back. So let's say name and value. So I get back exactly what I want. And if I don't want scores, I wouldn't ask for it, and that method won't be called. Right. So the other thing that's obviously a big benefit is when we do queries on collections, because making a query onto a person that has 70 fields and a REST endpoint is you can argue, still fairly acceptable. But if you make a query that does some sort of a search and it turns multiple people and they all have 70 fields in, that quickly gets quite big, the response. Obviously, you can do something like this where I actually return a list of persons in GraphQL. I mark it as a query and I should be able to do people now. And I can say, just get me the names of those people. And even though it's a lot of people, it's not a lot of data because I still ask exactly what I want. So that's one of the big benefits of GraphQL. Right, so up until now, we've done queries. We've specifically asked for specific data. And if we want to change data, so let's say update the person, I can do something like this, where I have a method that I annotate with @mutation. And now I pass a person in. So this will now be an input object that I pass in. I'm just going to actually copy this from the GitHub page because it's quite a lot of typing. But as an example, if I want to add a person, so I now create a mutation. I add a person and now I pass in the actual person object. In my case, I only add a name for Phillip, but I ask back the ID, the names, the surname, profile picture, and website. So if I do that, I'll get an ID back, which is now been generated by the system. The name, which is the one that I provided, but the rest is null because I haven't actually set it. So I can now go and update the person and pass in 101 and then the rest of the information. And then I get, populate the rest of the fields. And similarly, I have a method that I've annotated with @mutation that allows me to delete a person, where I can just pass in the ID, so ID 101, and then it'll get me back that information. So now that person's been deleted, I got the same data back. And obviously, if I do it again, that person doesn't exist, so I wouldn't be able to get the data back because we've deleted the person. So that's very quickly. Let's exit here. That's very quickly the mutations part. Right. So let's go. So one of the other nice things about GraphQL is the ability to do, or the way in which it does error handling. And there's two ways or two types of errors that you get. One is a validation error. So something like this, where I'm asking a field on top of scores and that field doesn't exist. You'll see that even in the front end here, it will be able to tell me that this doesn't exist because it has knowledge because of the schema. So it knows that this is not a valid field. But even so, even if I do that, it will get me back an error. And GraphQL will always put errors under errors and data under data. You'll see that I didn't get any data back, but I did get this error back. And it will then tell me what the problem is. So that's a validation error. And that actually happens before it even hits your code that you've annotated with @query or @mutation. We will intercept it and immediately say that this is not valid. So that's the one type of error. The other type I had to simulate. Let's see if it's in here. Yeah. So what I've done is I've added a new source on top of person and called it scores2, which is kind of exactly like scores. It returns a list of scores. But I simulated the failure in the scores2 example where I just throw a normal Java exception. So to simulate a failure in, let's say, the score system, maybe the score system is down or slow or timed out, or it's a problem with the data or whatever. So if I now make a query to, let's do person again. So person, person name, and we'll ask back the name, surname. And now we'll do scores2 just to simulate the error. Or let's do scores first so you can see what works, what it looks like when it works. So we want, that's the one that we've been using up until now, and we get back all the data. Let's say the score system goes down, and now it throws an exception. So I can get the exception in the errors. I can say that the scores is not available, but I can get a partial result back. So I can still get the person data back, which is quite handy. It does mean that you don't have to fail fully, but you can kind of show something on the screen potentially. And this is just a normal exception. There's a rule in the specification that will treat business exceptions, so checked exceptions in Java, as something like this, where you can get the message back from that exception. And runtime exceptions will just throw a server error and it will hide the actual message for security reasons. And you can switch, you have a white and a black list to switch them on or off depending on your needs. Right. So up until now, we've shown how you can add scores to a person, even though it doesn't exist in Java, you can add it in GraphQL. But very similarly, you can add more source fields onto an object. So you can add more source fields onto person, or you can add a source field onto score, which means that person will use score, will use event. So you can build fairly complex graphs in your code if you want to. Whether that's good or bad thing, that's, I guess, is debatable. But what we can do is we can say that a score is maybe made up of a bunch of events. So an event would be Phillip went to the gym, or he took 5,000 steps and we figured it out from his watch, or he drove to work this morning and he didn't make an accident. So we can now add a new method which will return all the events that's tied to a specific score and do something like this. That allows me to, now if I go back there, that's the normal one. If I want to understand what is the events that make up this score, I can ask for events, and only now we will actually make the score. So let's say we want to see what is the action that's been taken, what's the date, time, and the value. So now I get this back, that this person has had a driving score of 11. It's made up of a drive and a drive on that date, and that was the value. Right. One of the other things that we support in the specification is support for JSON-B annotations. So because current users that use JAX-RS has the support, we decided to add this. So you can actually format dates and numbers using JSON-B date format or JSON-B number format. In this example, I'll format this field, which is a date time field called when, and make sure that it has this format. So rather than using date time, I'll use when, and now this date will be a nicely formatted date. All right, so there's a nicely formatted date, and similarly, numbers, number formatting. And similarly, names, so I can change the name. If I don't want it to be salary, but monthly salary, I can add this annotation. Here's a JSON-B number format, which will use a currency indicator, and this will be South African Rand, so this will give my salary in South African Rand. I can use JSON-B transient to hide a field, And then depending on where you put this, if you put it on the field, it will be applied to both the input and the output object. So if you add it only on the getter, it will only be on the output object. And if you add it only to the setter, it will only be on the input object. So if I want to hide the bonus on only the output, I can add transient on get bonus, but it will still be something that I can pass in as an argument because it's not on the setter. Then we have some other annotations, which is similar to the ones you've just seen, the JSONB ones. For the case where you don't want to use JSONB or you don't have JSONB, you can use a specific GraphQL annotation, which does exactly the same thing. So @name is the same as JSONB property. It will rename the field. And again, if you want to rename it on the output object only, you put it on the getter. And then you have number format, which looks exactly the same. And you have date format, and you have @ignore to kind of manipulate the data. You can also put the actual GraphQL annotation number format inside a list. So to apply the format in objects that's in a list. Or a non-null you can add inside a list, which means the list itself can be null, but if it's not null, there's not allowed to be elements in it that's null. We also have a default value as an annotation that you can add to an argument. So in this case, we have a query operation called with surname, returning all the people that has a specific surname. And if you don't pass in a surname, we will use Kruger as the default. Then there's some other annotations that I'll just quickly scan over because they're not that important. But if you remember the concepts of GraphQL, we have a type, which is really what you get back, an input, which is what you pass in, and then an enum interface and source that we've spoken about. So you can actually annotate a class with @type if you want to change the name of that class. You can say @type, and if it's a person, but you want to call it people, then you can do @type and give it a new name. By default, it's not needed. The implementations will go and scan all your operations that you've marked with that query or @mutation, and it will follow the tree to figure out all the input parameters that you've passed in and what you return. And if it's complex objects, and if an object contains a list of another object, and maybe that object contains the original object, it will find the whole path and build schema based on it. But you can also annotate it. Right, and then the last demo that I want to show is the introspection. So the way to look at yourself. So that's built in by default. So I can go and say, actually show me the schema types, and I only want to get back the name and the kind. And now I will get back all the types. So there's action and address, and it'll tell me it's an enum or an object or an input object. That's a nice way, and that's kind of what the GraphQL frontend uses to be able to actually build the code inside that comes with this frontend. All right, we have 10 minutes left, so that's kind of the end of all my demos. I'm not going to switch back to presentation mode because otherwise I have to stop sharing again. At the moment, the known implementations of the specification is SmallRye is the one that I've shown you now, which I just ran on Wildfly. It will become the implementation that gets distributed with Wildfly and Quarkus. And I'm actually busy working on that right now. And then there's an implementation called Speaker, which was a library, or is a library that existed before we started with the specification process. It's a guy called Bojan. He's also on the specification committee. So a lot of the concepts that's in this spec comes from that library. But that library itself is also now an implementation. Okay, so we have 10 minutes left. If there's any questions, please interrupt me, ask the question. The last section, I wanted to kind of show what is next. So what are we working on at the moment? And obviously there's a disclaimer with that. That everything that you see there is not necessarily how it's going to be, because we're still working on it. It's a work in progress. So one of the things that we plan for the next version, which will be 1.1, is a built-in client. for GraphQL, because at the moment we have a very easy way to create a GraphQL server, annotate your method with that query, but now somebody needs to consume it. So we've shown a front end using GraphQL how to do it. But actually, if you want to do it from a Java system, so if you think of microservices talking to each other, to be able to build up a HTTP post with that JSON in is quite a lot of work. So we want to build an easy way to do this in a client. So we have two types of clients. We don't really know what to call it yet. It's going to be called either low level or dynamic or fluid or something. We don't know yet. But this client will be fairly low level, hence the name. So let's say I want to do this query onto a server, which is basically saying, get me all the heroes in New York and get me back their name, current location, and the name of the team that they're affiliated with. So I'll be able to do something like this, some builder pattern where I can say this is a query, add a root field that might change to add operation or something. Here's the arguments that you need to pass in. This is the fields I want back. So this, if you look at this, it looks kind of the same as the actual query. The formatting is similar to this. And this will allow you to actually make that call, and it will get back either just a string or a JSON object, or maybe allow you to actually pass in the type to which this should bind to, kind of similar to JAX-RS client. So that's the one part of the client. The other part of the client would be, again, we're still debating on or deciding what the name should be, but it will be something like high level or type safe or something like that. And this is going to be more comparable to MicroProfile REST client, which is a type safe client. So again, if I want to make this query, which is basically saying, get me the name and the superpower of all the heroes that's in New York, then I will create an interface and call it the API. And then I'll list all the operations that I'm interested in. In our case, we're only interested in all heroes in a specific city. And I'll annotate it with GraphQL client API. And I never have to actually create the implementation for this interface. I can then create an object called superhero and put the fields in that I'm interested in. So it won't be all the fields that the server-side superhero has, but only the ones that we're interested in. So in our case, these two fields. And then I'll be able to inject that API inside my application and make a call on top of it to say, get me all the heroes. And it will actually be type safe. It will get back the heroes. So that's the second part of the client. Some of the other concepts we are busy with for the next version or the next version is a concept of request info or request context or something like that, which is an injectable object that you can inject anywhere in your code, which will have information of the question that's being asked. So what this will allow you to do is that to optimize, as an example, your database query. So even if I don't use at source, if I only fetch my data from one database, so I don't have two separate systems, to go and fetch all the data just to filter out the fields that's been asked for could be an expensive SQL query. And this will allow you to actually inspect what has been asked, optimize your SQL query, and use that to do the query. Pageable. So even though at the moment you should already be able to build pageable queries by just passing in, manually passing in the offset and the limit as parameters, we will potentially make it easy where you can just annotate some operation that returns a list of something with @pageable or something like that. And we will then add these offset and limit fields for you just to make it easy. Then security, there's quite a lot of work that we have to do on security. It's quite a hard thing, or this is one of the things that I think is more complex in GraphQL than it is in REST, because in JAX-RS you can secure every endpoint in a specific way. In GraphQL, there's only one endpoint. So you can't actually secure it on the endpoint. But we need to basically solve authentication and authorization, and we'll potentially look at using the current annotations in the Java security specification And you will be able to annotate, let's say, a specific object or specific field with that security annotation. And if somebody asks a question that includes something which they're not authorized to see, we will use partial results to pass back what he can see, with an exception on what he can't, or something like that. We actually haven't decided yet. One of the other things that we are working on is integration with other MicroProfile APIs. So as an example, add metrics to every call, or tracing, or fault tolerance, or JWT propagation in the case of security. And then there's quite a lot more. You can actually go and see all the issues that's on our issue list. And if you're interested, vote for the priority of these. And that's me. That's the end of my presentation. You can find the presentation online. There's the URL, and you can find the example that we've used also online. Like I said, you should be able to get it going on your own machine. And then, I think we have about 4 minutes left for questions. If you don't have a question now, but you think of something later, find me online, either on Twitter or you can email me. That's it.
Oh, okay. I have 2 questions.
Yeah.
A moment.
When it enters the MicroProfile. So is this question, when would it be part of the umbrella specification? Because if that's the question, I'm not sure. Like I said, we are a standalone spec at the moment under MicroProfile. Whether or not we will even ever be part of the umbrella is up to the community. So the community will have to go and ask for it. And once enough people ask for it, then it will happen. It's not a guarantee.
Oh, wait. What questions?
Well, I mean, I can give you my opinion, but I'm definitely not the expert on the usage of GraphQL. It's used a lot outside of Java. So in the JavaScript world, I think there's a big hype around it, or even it's becoming the standard in communicating between services on the JavaScript world. A lot of support for it there. I think it's fairly new in the Java world. But I think the problem, as I explained it, is fairly common, and hopefully people can see that this is a solution for that.
Oh, okay. No having my questions. Philip, final words?
From my side, nothing. As I said, if you have questions, find me online. There's a blog that Jean-Francois James just wrote, I think yesterday. I retweeted it this morning, that goes into more detail of the client. He's working on the client. If you're interested in that, you'll find it on Twitter, on my Twitter. I've retweeted it. And otherwise, if you have questions, just ping me, please.
Okay. Thank you.
Thanks.
Great lecture. Thanks. Bye.
Cheers. Bye.